In the last video, we saw how the CPU switches between processes. We saw an example where process A was waiting for disk, and the CPU switched to process B. Now the next question is, when does the CPU decide to switch like this? There are two main ways this can happen. Let's understand them one by one. The first is called non-preemptive scheduling. In this approach, the CPU switches only when it has to. For example, when a process is blocked, like waiting for disk, or when a process finishes execution. In these cases, the process cannot continue. So the CPU naturally moves to another process. You can think of this like a polite system. A process keeps using the CPU until it either finishes or gives it up. Now let's look at the second approach. This is called preemptive scheduling. Here, the CPU can switch processes even if they are running perfectly fine. But why would we do that? Imagine one process keeps running for a very long time. If we never interrupt it, other processes may never get a chance to run. That would be unfair. So to solve this, the CPU uses something called a timer interrupt. After a fixed amount of time, the CPU generates an interrupt. At that moment, the CPU enters kernel mode and starts executing operating system code. The scheduler then gets a chance to decide, should we continue running the same process, or should we switch to another one? If it decides to switch, a context switch happens, just like we saw in the previous video. This is what makes preemptive scheduling powerful. It ensures fairness. Every process gets a chance to run. Most modern operating systems use preemptive scheduling for this reason. So to summarize, there are two ways the CPU switches between processes. In non-preemptive scheduling, a process gives up the CPU only when it cannot continue. In preemptive scheduling, the CPU can take away the CPU from a running process using a timer interrupt. And this brings us to the next big question. If there are multiple processes ready to run, how does the system decide which one to choose? That's where scheduling algorithms come in. And that's exactly what we'll explore in the next video. So make sure you subscribe, and I'll see you in the next one.